Manufacturing Feasibility Capacity Assessment for Product by Optimization of Resources. This is our final year project. Our project was done at Addition and Company Private Limited. Our internal guide is Mr. Dr. R. Mariappan and external guide Mr. V. Ravichandran. I myself PUROSOTTAM SENGUPTA and my project partner is Rahul KANTI NATH. Company profile. It was in 1886 that Tom Leuker, a gentleman from Scotland, took over the Addition press and which was initially founded by Mr. NATH. Tom Leuker didn't stop by making Addition a printing press company. He advanced it and he converted it into a company for making water-ready watches, which was known as Addition Company Limited. In 1914, Leuker, at the age of 57, returned to England. Meanwhile, his two sons took care of Addition and Company Limited. In 1943, Leuker sold Addition and Company to Simpson, and after that, it was handed over to Sri Anant Raman Krishnan, who is the present chairman and founder of the company. Our company is a metal cutting tool making company. Its major customers include Titan, Maruti, Telco, Hale, HAL, heavy machine tool company, and other two-wheeler companies, etc. Products. The company is famous for making its cutting tool products, which include center drills, end mills, group thread taps, milling cutters, reamers, twist drills, and broaching tools. Now let's come to our project abstract. Manufacturing Feasibility Capacity Assessment for Product by Optimization of Resources. It is carried out at Addition and Company Limited, Sipcot, Chennai. It is a project which aims to make perfect utilization of available resources while producing a broaching tool. The project is concerned about the pre-heat treatment operations of a broaching tool production, which includes turning, facing, milling, drilling, etc. In this project, we will study about the different machines used in pre-heat treatment process of a broaching tool in details. We will do a time synthesis and optimization of resources for broaching tool production. Here, in this project, we will calculate the time required to produce a broach tool by using various machines, and we will try to sort out ways for perfect utilization of the available resources. Time for production is calculated based on broach length, diameter, and number of teeth. We perform time synthesis, and at last we will produce a monogram basing on which time utilization can be maintained. The diagram which we can see is a diagram made in AutoCAD which shows the broach section layout. It is the section where the project has been undergone. It shows different grinding machine sections and milling sections, as well as sections for gear hub cutting. Our main concern was with pre-heat treatment operations, so we have done most of our job in the milling and turning and center lathe part of the layout. Now let us give a brief description about our project. Our project deals with broaching tool, so let's have a brief description about what is a broaching tool. A broach is a series of single point tools adding successively in an axial direction along a tool body or holder. Each sequence tool varies in size, shape in manner that allows each tool to cut a chip of proper thickness. The end teeth of a broaching tool determines the exact shape of the hole. Classification of broaches. Broaches can be broadly classified into two types, external and internal. External broach can further be classified into just one, that is a surface broach. Internal broach consists of four types: round, cubist, spline, and polygonal. Spline can be further classified into straight spline, serration, involute spline, and helical. The broach nomenclature. The diagram shows a broach nomenclature, which is the specific design of a broach tool. In the diagram, we could see the pull end, the rear end, the front pilot, the roughing teeth, the semi-finishing teeth, finishing teeth, and the rear pilot. The cutting length of a broach tool is the main live area of a broach tool. It is used for removing material. The cutting length comprises of the roughing teeth, the semi-finishing teeth, the finishing teeth, and the other rear pilot and pull end and the rear end are just for fixing and for pulling purposes. The general tool materials for broach manufacture. The chart shows the different metals and the materials which are used by our company in producing a broach tool. The cheap products include M2, M35 and M42 types of metals, which comprises of carbon, tungsten, chromium, vanadium, molybdenum and cobalt in specific percentages to make the metal much strengthy and to have high tensile strength. This diagram shows a broaching machine, which is generally a vertical broaching machine, and this is a horizontal broaching machine. These machines are used in broach tool production. Introduction. Our project aims to manufacture a product, broach tool, by optimization of resources. It means we have to find several ways in which we can make a perfect utilization of the available resources in the company. This can be done by the synthesis of time. We have to work in such a basis that the production process will be a productive and a much effective one, which will be effective for the company as well as for the customer. We'll calculate the time required for the production of a single broach tool and we'll check that the time is properly utilized effectively. Procedure. At first, all the machine manuals are studied in details and we have made a format which is much easier to study by the company people. This specification format is useful both for us as well as the company personnel for studying machine properties. This format consists of specifications like plant number, spindle speed, power required, etc. for a particular machine. An example of this specification format is just given. This chart or format which is shown in the screen is the machine specification format. It consists of the machine number, the make type, the specification table which consists of the overall dimension, clamping area, number of width, number of slots, power operated. It consists of milling spindle, feet, number of feet, feed range both for longitudinal and transverse, and power of the main motor as well as feed motor. Our next chart is just a summary chart which shows all the machines which are required for the preheat treatment operations. It consists of all the specifications in details which could be made into a chart and can be pasted in the shop floor, which will be quite effective, and by seeing this the person from an outside or the company person as well can understand that what is the sequence of the operation and which machines are performing which operation. Formula for broaching tool production design. Generally a broach tool consists of three sorts of formula: a drilling formula, a milling formula and a turning formula. In the drilling formula you have to find the cutting speed where the diameter, the RPM is given. The RPM formula consists of the cutting speed, the smaller diameter through which the RPM could be find out, and then we can find the millimeter per revolution, the millimeter per minute, the cut time and the MRR. In the milling formula you have to find the cutting speed, the RPM, the millimeter per tooth calculation and the force applied millimeter per minute calculation. Turning formula to find the cutting speed, the RPM and the cut time. This slide shows the calculations which I have done manually to find the cutting speed, the RPM and the amount of material removed per teeth. The given formulas are stated in the formulae chart and the calculated value has been calculated by us. This chart shows the different types of broaches which are produced in our company. These have been designed by us and have been made in CATIA software. We can see that the screen consists of four sorts of broaches: the spline, the round, keyway and the surface. Time synthesis. This is a major part of our project. Time synthesis is an act of process planning and exercising continuous control over the amount of time spent on specific activities, especially to increase effectiveness, efficiency and productivity. It is a meta activity with goal to maximize the overall benefits of a set of other activities within boundary conditions of a limited amount of time. Time management and synthesis may be aided by a range of skills, tools, techniques used to manage time when accomplishing specific tasks, projects, goals, complying with a due date. Initially, time management referred to just business or work activities, but eventually the term broadened to include personal activities as well. A time management synthesis is a design combination of processes, tools, techniques and methods. The time management is usually a necessity in any project development as it determines the project completion time and scope and a much effective form of production of a project tool. Next after we studied the machine specification, we made chart where we wrote about the types of approach tool which is produced by the company, the standard operations machines which are performing those operations and the sequence in which they occur. After this we made several bar graphs based on these data and estimated the number of approach tools being produced by the company annually and also the rate of their production. The chart and the standard operations is given below. This slide shows the different standard of operations of the sequence in which a approach tool produced. The chart also shows 4 types of approach tools: spline, round, keyway and surface, and the sequence in which they are produced one after the other in a machine, and the plant number of the machines which are performing these operations in the company. The horizontal bar shows the standard of operations, whereas the vertical shows the sequence and the plant numbers in which they occur. Through these charts you can understand that which sequence follows the next. Suppose in spline, as we could see that their numbering is given as at first raw material cutting, then facing centering, then pilot flip turning, and it goes on. Whereas the square milling and the teeth cutting are not required in this section, so we have put cross in that. Similarly in the keyway, as we could see that raw material cutting is at first, and the second goes with square milling as it has been numbered 2, but facing and centering and pilot flip turning are not there, so it has been marked as cross. This slide is just a continuation of the standard of operations. This graph shows the plant number, the number of operations in horizontal and vertical axis respectively. By this graph we can easily understand that which machine is producing which amount of broach tool and the maximum number in which they occur. The number of operations also shows that which machine is performing which number of operations. As we could see that machine number 1211 and 1210 is performing maximum number of operations, so it has been stated up to 7. The next graph shows the type of broach and the number of operations in vertical and horizontal axes respectively. It shows 4 broaches: surface, keyway, round and spline. This graph shows that which broach tool requires which number of operations. The third graph shows the number of plant used and the type of broach in its vertical and horizontal axes respectively. We could see that the number of plant used in round broach is maximum, that's why it has reached to 14, followed by spline, then keyway and surface, it's minimum. Slide shows the sequence of operation and the time required based on different length and diameter of the cutting raw material. The sequence of operations as could be seen is first raw material cutting, then facing centering, then front pilot and flip cutting. In each table we have shown 3 specific lengths and diameters as examples, which has been found from the company, and we have estimated and calculated all the time required for each sequence of the operation, and at last we have given the total time required by summing up all the individual times. For example, with length 1440 and diameter 27 mm, the total time required is 7 hours to 8 minutes. This is a monogram or a bar graph which shows the diagrammatic representation of the time required in the broaches of 3 different lengths for a spline broach. We could see that they are demarcated with 3 different sorts of color. This different color shows the different length of the broach tool. The next from the round broach, and similarly in this slide also we have shown the sequences of operations based on 3 determined length and diameter which was found from the company, and at last the total time has been calculated by summing up all the individual sequences of operations. This is the monogram or the bar graph which shows the time required for a round broach synthesis based on 3 different lengths and diameters, and this is also demarcated by 3 different colors. Third is the QA broach. This QA broach also consists of the sequence of operations which are a little bit different from the round and spline, as the QA formation is required in this case. This consists of a special sequence such as taper milling and teeth cutting operations. And here also the 3 estimated lengths and diameters which are found from the company are taken, and the time is calculated individually for each sequence of operation, and total time required is calculated by summing up the individual sequences. The QA broach, this is the QA broach monogram or the bar graph which shows the time in minutes, and the different lengths are demarcated with different colors. This is a surface broach. The surface broach is a surface broach which is quite similar to the QA, but few steps are added as well as are not there, which makes it different from the QA. The surface broach is a type of external broach, and we could see that here also 3 different lengths and diameters have been estimated, and the time has been calculated and total time has been summed up. This is the monogram for the surface broach, and different lengths are demarcated with different colors stating the time in minutes for different lengths and different diameters. This is a slide which shows the difference in the 3 sorts of time, that is the standard time based on the machine tool manual, the estimated time which we have estimated and calculated, and the actual time taken by the employees of the company to produce that broach tool. Here also we have shown 3 different lengths. Suppose length 1440, diameter 27, length 1360, diameter 25, and length 1560 and diameter 25 mm. There is a bit variation between the standard time and the estimated time and the actual time as well. Conclusion. This project report is a capacity assessment for effective utilization of time for producing a broach tool. The main goal of our project is to optimize the time required for a broach tool production in its pre-heat treatment operations. We have collected data regarding all machines and calculated the actual time of the production process. In this project report, we have given a clear description about our company while the project was undergone. We have shown details related to the process of broaching. We have explained details about the process with specific diagrammatic representations. Regarding our topic, manufacturing feasibility capacity assessment for product by optimization of resources, we have written the machine details, the specifications based on the machine manuals. We have made charts where all the processes are explained in details along with the plant numbers of machines. All processes and their standards of operations are checked and their respective time of operations are stated. We have sorted out the time losses and estimated the effective production times. We hope our project will be helpful for the company, and we will be highly obliged if the company implements those proposals given by us. The charts and the graphs which have been stated by us and designed by us will be quite helpful for the company personnel, because these things can be attached or pasted in the shop floor areas, where by looking at them they can easily understand the sequence of operations and the machines undergoing these operations. It was a great honor to work in the broaching section of such a renowned company with the staffs. We are thankful to them and for their help and cooperation and for making this project a successful one.